Hey guys, Camille here from Prep for Success, talking about two or more variable algebra. Now, really, the goal with two or more variable algebra questions on the SAT and the ACT is to determine the relationship between the variables, and then to manipulate the equation accordingly based on what the question is asking. Now, for example, let's say we had a question that gave us z equals 3x plus 12 and 2z equals 4x plus 8. Now, in a problem like this, all we have to do is manipulate the equation accordingly. Well, multiple ways to do this. You can solve for z, solve for x. My first thing is I see that we have z equals 3x plus 12 and 2z equals 4x plus 8. So immediately I'm thinking, well, let's multiply everything on both sides here by 2 in order to get 2z. That will lead us to getting 2z equals 6x plus 24. And we know that 2z is also equal to 4x plus 8, as well as 6x plus 24. So now we can set 6x plus 24 equal to 4x plus 8, and then solve for x. Minus 4x on both sides. 2x plus 24 equals 8, minus 24. 2x equals negative 16, divided by 2, x is negative 8. And now if they asked for z, we can go back and plug in what we got for x into either equation. And then we would get 2z equals 4 times negative 8, which is simply negative 32 plus 8. 2z equals negative 24 divided by 2. We get z equals negative 12. Now, a problem like this could ask you for the value of x, the value of z, the relationship between the two. Either way, we have solved for both, and that's how you tackle a like-minded problem. All right, now let's take a look at a little bit of a different problem. More challenging, still two or more variable, but the point is to still find the relationship between the two. So let's say we have 8y over 3y plus 1 over x, and it's equal to 2. And the question may say, what is the relationship between y and x? We don't want to solve for either of them. We just want the relationship between y and x. Well, without having to do a lot of math and spend a lot of time on a problem like this, we can try to just substitute this entire piece with another term. What do I mean? Well, 8y divided by what gives me 2? Well, 8y divided by 4y would give me 2. Therefore, everything here, the 3y plus 1x, needs to be equivalent to the 4y. Therefore, we have 3y plus 1 over x equals 4y. Subtract by 3y on both sides. That would give us 1 over x equals y. Therefore, the relationship between y and x is an inversely proportional relationship. So our answer could be y equals 1 over x, or our answer could also look like multiply by x on both sides, and it could be something like this, 1 equals yx. Whichever answer choice appears on your answer choices between A, B, C, D, and E, you can pick either of the two because they're both equivalent. So once again, if they ask you for the relationship between x and y in a problem like this, the easiest and fastest way to solve this problem would be to actually just ignore everything here and realize that 8y divided by 4y gives you the 2. So then we can set 3y plus 1 over x equal to 4y, solve for that, and then we know that the relationship between y and x has to be y equals 1 over x, or y times x equals 1. Now let's go ahead and apply the concepts we just learned. Let's take a look at number 1. Here we have if y equals 3x plus 8, and y equals 5x minus 4, they're asking for the value of x. Now, it's all about figuring out the relationship between y and x, manipulating the equation in order to solve for x in this case. So because we have these two equations, two variables, but they're both equal to y, we can actually just set them equal to each other and say 3x plus 8, which is equal to y, is actually equal to 5x minus 4 because that's equal to y as well. Now we have these two equations, and we'll just solve for x. We got 8 equals 2x minus 4 plus 4 on both sides. And we've got 2x equals 12. Our answer will be divided by 2, x equals 6. Now, let's take a look at number 2. If x plus 3y equals 6, and 2x minus 2y equals negative 8, what is the value of y? Well, in this case, instead of using substitution, I would like to actually use elimination, where if I multiply the top equation by 2 on both sides, that would result in 2x plus 6y equals 12. And the bottom equation, I have 2x minus 2y equals negative 8. I can now subtract the two equations from each other, and that would give me 2x minus 2x, that would cancel out. 6y minus negative 2y would be 6y plus 2y, therefore that's 8y. And then 12 minus negative 8 would simply just be 12 plus 8, which is 20. Therefore, y divided by 8 would just be 20 over 8. And if we simplify that, that's simply 10 over 4, or 5 over 2 as our final and simplest answer. Next, let's take a look at numbers 3 and 4. In 3, we have AB equals x, and x equals BC. Which one of the following is equal to C? Well, because they're both equal to x, I will actually set AB and BC equal to each other. Now we're trying to remember solve for C. What is C equal? Well, both of them have a B, so let's cross that out and divide by that. And now we know that A is equal to C. And just like that, we know our answer is C. So C is equal to A simply because we were able to manipulate the equations. Here we had three variables. We had A, a B, and C, as well as the x, so actually 4 variables, and we were able to manipulate them in a way where we got rid of the x by setting the two equations equal to each other, divided by the b because they both had a b, and ultimately came to the conclusion that A equals C. Now, let's take a look at number 4. X plus 3 times y minus 1 equals z. What is the value of y minus 1? Well, instead of solving for y, I'm just going to keep this y minus 1 just like that. Simply because that's what they're asking for, that's what I'm going to do. We want to do what's easiest, quickest, and most efficient. Remember, the less steps we take, the better, because we lower our chance of getting a question wrong, and we save time. So let's minus x initially. So we have 3 times y minus 1 equals z minus x. Then we'll be dividing by 3 on both sides. And simply we get y minus 1 is equal to z minus x over 3. And that's our final answer. We didn't have to solve for y. We just solved for y minus 1 in terms of x and z. Furthermore, we've got questions 5 and 6 here. Starting with number 5. If 3x plus y plus 5z equals 24, and 3x plus 5z equals 18, what is the value of y? Now, in this case, we would just use simple elimination because both equations have a 3x and a 5z because we want to know what this one y is. So 3x minus 3x cancel out, 5z minus 5z cancel out. That leaves us with y minus 0, which is just y, and then 24 minus 18, which would be 6. So the value of y is simply 6. Now next for number 6, we're taking a look at if x minus y equals 2 and x squared minus y squared equals 8. So x minus y is 2, and then x squared minus y squared equals 8. What is the value of x plus y? So they don't want to know what x is, they don't want to know what y is, they want to know what x plus y is. Well, in this case, it's actually going to be easier to break apart this equation of x squared minus y squared and simplify that, just because solving for x and y would be rather laborious and maybe even quite impossible in this case, especially within the given time frame. So if we just do x squared minus y squared and simplify that into x plus y times x minus y, well, we know x squared minus y squared is just 8. They're asking us for x plus y, and we already have x minus y. X minus y is simply 2. They've given us that over here. So 8 equals a number times 2. So this number is going to have to be 4. Therefore, x plus y is simply 4. And we can come to this conclusion without caring or needing to know what the individual value of x or the individual value of y is. We just know that x plus y is equivalent to 4. Now we've got numbers 7 and 8 a little bit more challenging than the questions we did previously. So let's take a look at these two. This, once again, is the exact style of either the SAT or the ACT, where it's this creative thinking. It's thinking outside the box. And with number 7, they're telling us that x squared minus y squared equals 55. And then they're telling us that x plus y is 11. And now they want us to know, what is the value of x? Well, x squared minus y squared equals 55. Well, let's simplify x squared minus y squared. That's just x plus y times x minus y. And x squared minus y squared, we said, was a value of 55. We set that equal to x plus y. They told us that right here as well, where we had 11. And x minus y would have to be what number times 11 equals 55? So x minus y would have to be 5. Therefore, we can come to the conclusion that x minus y is 5. Now, they're not asking us for x minus y. They're asking us for the value of x. Well, now if we have these two equations right here of x plus y equals 11 and x minus y equals 5, we can simply just do substitution, elimination, whatever we choose. But in this case, I would do elimination. I would actually just add the two equations of x plus y equals 11 plus x minus y equals 5. And x and x gives us 2x. Y plus negative y would cancel out. And then 11 plus 5 would be 16. So now we have 2x equals 16. So we divide by 2 on both sides, and we would get x equals 8 as our final answer. And next, let's take a look at number 8. If x squared minus y squared equals 12, and x plus y equals 4, what is the value of x minus y? Well, as we've done before, we know that x squared minus y squared is the same thing as x plus y times x minus y. And we know x squared minus y squared is 12, based on what they told us within the problem. And then we know that x plus y is simply 4. They've told us that as well. And so now we have 12 equals 4 times what number, which is representative of x minus y? That number is going to have to be 3, because 4 times 3 is 12. Therefore, we can come to the conclusion that x minus y equals 3. And last but not least, we have numbers 9 and 10, the most brutal questions that we'll run into for 2 or more variable algebra. Let's take a look. Number 9, here we have if xy equals 5, and then x plus y equals 6, then x squared times y plus x times y squared equals 1. Well, we have to know that we need to use y equals 5 and x plus y equals 6 in order to somehow figure out what the value of x squared times y plus x times y squared is. In this case, we wouldn't just solve for x, we wouldn't just solve for y, it would be way more tedious that way. The quick shortcut and the creative method to tackle this question would be to realize and simplify what the question is asking us. So x squared times y plus xy squared is the same thing as xy times x plus y. How do I know that? Because they both share an x, so I can pull out the x from both of them, and they also both share a y. So I could pull out the y from both of them. And then if we pull out an xy from both of these two terms, the first term is left with just an x, and the second term is left with just a y. And look at that, we already know what xy is, which is 5. We know what x plus y is, which is 6. Therefore, we can come to the conclusion that 5 times 6 would be what they're asking us of, which is an answer of 30. Therefore, our answer is 9C. And last but not least, we have number 10. If x squared plus y squared equals 2xy and x equals 3, what is the value of x plus y squared? In this problem, I would replace my x's with 3 initially, within the two equations that were given, use that, and then simply get 9 plus y squared equals 6y. Now here I'm starting to see that we've got a quadratic, so I want to set it equal to 0. So it's minus 6y on both sides, and that would give us y squared minus 6y plus 9 equals 0. Now with that equation, I'm going to take that and simplify it and break it down into y minus 3 times y minus 3 equals 0. And that can also be rewritten as y minus 3 squared equals 0. So if they're asking us what is the value of x plus y squared, well, we know that y minus 3 squared equals 0. Therefore, we know y would have to be 3. And this is because the only value that we can plug in to get us 0 would be 3 for y. So we know x is 3, we know y is 3. Therefore, we can just simply plug that into x plus y squared would be 3 plus 3 squared, which is 36. Therefore, our answer would just be D.